Hey everyone, we're going to look at the last three in section 3.2. That's 23, 24, and 25. They're graphical type problems dealing with the derivative. So in 23, we're given the graph of a function. This is the blue curve here. And then we're to select which one of these is the graph of this function's derivative. So remember, the derivative tells us what the slope of the function is at any point. So if I'm looking for graphical examples, when I look at the graph of my function, one important point would be, where is the derivative equal to 0? Where is the slope of the tangent line 0? In other words, when do we have horizontal tangent lines? And the only place that's going to occur is at the tip of this graph, right? If we drew the tangent line at that point, it would be a horizontal line, right? The line that just touches the graph at the top there. Therefore, the derivative at that point is 0. At no other point is the derivative 0. At any point to the left of the place where the derivative is 0, notice if I pick any point here, the slope would be positive because the tangent line would be a line that has a positive slope. And anything to the right would have to be negative, right? The derivative at any point on this curve is negative because any tangent line would be decreasing. So I know there's only one location where the derivative is 0. And if I look at the graphs of these functions, which ones have only 1, 0? In other words, which ones touch the x-axis only once? Because remember, the value of the derivative tells us, right, the slope of the graph of the function. So notice there's 1, 0 here, but here it looks like there's 1, 2, 3 zeros, and here there's 1, 2. So these two right here right off the bat cannot be the derivative of the blue function, right? Because there's only one place where the derivative is 0. And it's right there, which coincides with this top one, right? So this is obviously the choice, but let's just look at a couple other things. Notice we said at any point here, the derivative was positive, which means, right, the graph has to be above the x-axis for values to the left of that 0, and they are. Any value to the right of that place where the derivative is 0, the derivative is negative, and which means the derivative has to be below the x-axis. Also, notice the sort of steepness. Initially, the slope is positive and getting more positive as we move through here, right? So that's what's happening. It's positive, getting more positive. And then real close to here, it reaches some maximum positive slope. And then all of a sudden, very rapidly, that positive slope right through this little curve section here goes from a very high positive number all the way to 0 very quickly. And that's why we have this quick drop off to 0. And similar, we can do the same sort of analysis for the right half where it's negative. And so this indeed is the graph of that function, the function's derivative. And so we'll go to the next question. All right, same sort of thing. We're given a function and we're asked to select its derivative. This one has a huge break in the graph, right? It's not continuous at x equals 0, meaning the function's not differentiable. Which means we're going to see an open circle perhaps, or something like that, vertical asymptote, something strange about the derivative. But the easy thing is to look at, for values of x less than 0, the graph of the function is a constant. And that means that the derivative at any point is 0, right? The slope of the tangent line is 0. The tangent line coincides with the function for values of x less than 0. So I know the derivative has to be 0 identically for all values less than 0. And if I look here, well, that's not the case, right? The derivative at -1, for instance, is 2. At -2, it's 4, right? Again, this is the value of the derivative, and it needs to be 0. So this one works, right? For all values less than 0, it is equal to 0. Same thing here, this one works, and same thing here, this one works. The last one here does not work, again, for the same reason, right? The derivative is only 0 at -1, but not at -2. It's 2, -3, it's 4. So it has to be 0 identically. And then for values greater than, so basically it's the second, third, or fourth option. For values greater than 0, the function is just a line, and it's obviously the derivative is going to be equal to the slope of this line. right? And the slope of this line is clearly negative, and we can see as we're going down, we go down 2 units over 1, down 2 units over 1, down 2 units over 1. So that means the slope is -2 divided by 1, or -2. So that means our derivative function has to be the function y equal -2. Okay, well, this is not y equal -2, this is y equal 2, and then it becomes y equal -2. This is y equal 2, so that's not going to work. This is y equal -2. This is the correct choice. And the last question. This one we're going to do some picking and sliding in. These, in this case, we're given the graph of the derivative and we're to match the function. So we're working in reverse from the previous two. Okay, well, we'll start with this derivative here first. The derivative is constant, meaning the function has to be a line, right? And it's the derivative is a constant, but it's always positive, which means the line has to have positive slope. Well, which one of these graphs is a line with positive slope? Obviously B, right? B has to be that one. Let's actually jump to the last one here. Here, the derivative changes, right? As x gets bigger, the value of the derivative is getting smaller. It's 0 right there, right? And then it's negative. So it's positive, 0, and then negative. So that means our function has to have one horizontal tangent line. One horizontal tangent line. So which one of these has one horizontal tangent line? Well, look at C. It's got a horizontal tangent line right here at this local max and right here at this local min. So it has two values, places where the derivative is 0. So this one here has two places where the derivative is 0. So this one is going to match up with this one. These two, where we have the peak of each of these has a derivative of 0, is going to match up with this one. And both of these are going to match up with this one. The derivative is, notice, a positive number, and then it's 0, and then it's a negative number. So it's a positive number, meaning our function has to be increasing, right? Any point to the left of where that derivative is 0 has to have a derivative that is positive, and that's the case. And notice it's positive, but as we move left to right, it's getting less positive, getting closer to 0, and that's exactly what's happening here. And then after that, it becomes negative, and it becomes more and more negative as we move to the right. So that's true here. So both of these functions are the same. And notice this graph of A and D, they're just shifts vertically of one another, right? It's like A is shifted down a little bit to get to D. So notice shifting up and down does not affect the graph of the derivative. This one matches up with this one. As we said, there's two places where the derivative is 0, at the peak and at the trough. In between, notice the function is decreasing, so the tangent line at any point is negative. Notice that's true. The derivative is indeed below the x-axis, negative between those 2 points. And then for values to the right of where the derivative is 0 here, any point on this point of the graph, the derivative is positive, which is true for the graph of our function here. And then it's increasing here, so the derivative is positive here as well. So this is true. There's one other question, and we already kind of mentioned it. Why two graphs have the same derivative? Well, these two have the same derivative because the value of the derivative at a particular value of x does not change if the graph is shifted up or down, right? Shifting it left or right, that's going to change things, right? If I shift this left or right, that's going to shift the graph of the derivative left or right. And if we scale horizontally or vertically, we're going to deform the graph. We're going to change the slope at all sorts of points, and that's clearly not going to have the same derivative. So those are the correct answers. Hopefully those make sense. And if not, as always, please let me know